This is number three. Number three is irrational inequality, and we have to express the solution as an interval and a graph on the number line. So first I'm going to start with, first I'm going to take note that number one, it does have x in the denominator. So I need to check this. I need to check that. But we can do that either first or after. It doesn't really matter. I'm going to solve for the x values that make the inequality true first. Um, so I'm going to rewrite one as x over x. So 4 plus x over x. I just combined these two fractions. And after that, I can easily cross multiply. Um, I'm going to write 4 plus x as x plus 4, and then x minus 1, so it's easier to FOIL out later. 3x is greater than or equal to x squared plus 3x minus 4. Then I say 0 is greater than or equal to x squared minus 4. And since I made this realization, since um we're gonna flip the inequality anyways, I'm just gonna do, instead of the inequality, I'm just gonna do equals x after I factor it out. So x equals x plus 2, 0 equals x plus 2, and 0 equals x minus 2. So that get that x is equal to -2 and +2. So that's the first step. My second step, I want to look for the domain just to be super sure that my numbers aren't, my numbers won't give me an undefined value. So I have two possible undefined values. It's when x minus 1 is equal to 0, so it can't equal to 0. And then when x equals to 0, and I can't have that. And that is equal to x is 1, and then x equals 0. So these happen to be in my um, range here. So hopefully we can see now what values work. I have -2 here, 0, +1, and 2. So even though the inequalities only gave me -2 and 2, I'm still wanting to be super safe and plugging in numbers all around here. But then again, I know that if the number does not work for 2, it wouldn't work for -2 either, because you would end up, um, you would basically end up squaring at some point. But still, to be safe, I'm gonna do it because the original inequality does not require me to square anything. So I'm gonna plug in. Plug in. Over here, I'm gonna plug in -3. Over here, I'm gonna plug in -1. Here, I'll plug in 1/2. This one, I'll plug in 3/2, and then here, I'll plug in 3. So basically, I have to do 3, -3 minus 1 is greater than equal to -3 plus 1, and then can do is equal to 3 -4 is greater than equal to, oh wait, oops, negative. So then this is equal to negative 1/3. So this is not true because negative 3/4 is farther negative than negative 1/3. So I know that it's not here. To plug in my next value, plug in -1, 3, -1, -1, 4, -1, +1, and I get 3, -2 is greater than equal to -4 + 1, which is -3. Let me see if that's true. Yes, it is true. So works here. I'll write it in blue so this difference. Okay. Number 3, I plug in 1/2. To plug in 1/2, this one's a little harder, but it's still the easiest fraction you could plug in. 3 over 3, so this is 3 -1/2. Okay, and then when you do that, you do basically 3 times -2 because you multiply by with the reciprocal. So it's equal to -6 greater than or equal to 8 because again you're multiplying by reciprocal to divide 1. So it's saying that -6 is greater than or equal to 9, which is definitely not true. So then X here. Now we plug in 3/2. So I did 3 over 2 minus 1 greater than 3 over 2 plus 1. Then I do, this is saying this is 3 1/2. So it'd be 6, but probably this time. Um, I just need to connect 6, and then it's greater than equal to 8 over 3. 8 over 3 is about, it's a little less than 3. It's about 2.66, and that is definitely less than 6. So 1 to 2 works. Now we have to check for our fifth number, +3. So I plug in +3 into it. I basically get 3 over 2 greater than equal to 1 over 1 is also 3 over 3, so it's 7 over 3. And so 3 over 2 is 1.5. 7 over 3 is 2.3. So this is not true. So this does not work. So now I have a clearly made number line. But if you want to even be more clear about it and actually graph it, this is how you would graph it. So I take the values I already know. I know in between -2 and 0, it works. To 1, it doesn't work. But 1 to 2, it does work. So my number line, and I take note that it's an equal sign. So to graph it, I would do full circle line here. Then I would do full circle here. And these are the only inequalities that work. So my last step, final step. So this was this is step one, step two, step three. So my final step is step four, is writing it in interval notation. I do brackets, -2, comma 0, bracket, union, 1, comma 2. That should be right. Okay, so that was the first question. Um, yeah. Now number four. Number four is similar, where instead, this is a new change. Instead of solving for the inequality, I'm going straight into the equal sign. The hardest part about number four is the factoring part of it, but I would just distribute out the x into all the terms. So I do x to the power of 3 minus 7x squared plus 10x plus x squared. I can just write it without the parentheses because I'm going to combine like terms. 0. So I do x to 3. I'm not going to combine like terms, but I'm rearranging it so I can factor out, um, being very strategic about the rearranging of it so I can factor out some numbers. Plus 10x is 10. I only know to do this because I noticed a pattern when looking at this equation. I noticed the coefficients are really similar. That's why I'm allowed to do that. So I can factor in x squared here. I can factor out 7x from here, plus 1, plus 10x plus. Let's do it. Okay, so I factor out the x plus 1s, and I can factor out of the whole equation and just combine these. So what is this saying? I'm saying that if I distribute this whole thing into each of these terms, I would get this, which is true. Just by distributive property, I get this. Okay. And now to factor further, instead of writing um, greater than, I'm just gonna write equals to because there's not there's really no point in writing, or in this case, it can't be equals to if you want to be really um, technical, but the equal sign would also. I only say that it's not, you would have to cross out the equal sign to make it true because this does not include values that make the equation equal to 0. So for this one, it's easy. I already know that x is equal to -1, but this one I have to factor. I know that 2 and 5 work as factors, so I can do 2 and -5. And then, so I know x equals 2, x equals 5, positive. Cool. So we can check, okay, will any numbers give me undefined value like number 3? There are none. So I'll just graph it on the number line. I have 2 and I have 5. And oh, my bad. I have 2, I have 5, and I have -1. So I just make sure I put all the numbers. So to be super safe, I plug in these. And this whole equation is easier because I noticed that it's 0 is what it's supposed to be less than. And so Um, because it's 0, I can just check the sign of my answer. I don't really have to be super sure. Of course, you can still multiply it out, but you don't have to because you're relying on the sign of it. So I'm deciding the numbers I want to plug in. I did -2, 0, 3, 5, and 6. These are just easy whole numbers that I can plug in. I'm just gonna think about it. It also helps that x squared minus 7x plus 10 is the same. There's two, and one is just being multiplied by x. So this is multiplied by a negative number. X squared would be positive minus times a negative would be positive again, plus a positive. So everything here is positive, but it's multiplied by a negative. So this is a negative number. In the same way, well, on the other equation, I have a positive, and a positive. However, these two numbers are the same. And because this one has a coefficient of -2, I know that this number will be bigger than this number. So my number, I will end up with negative number. So is this true? No, because negative numbers are less than. So -1 and less than -1 does not work. Now I will plug in 0 into the equation. It's easy because 0 multiplied, so I plug in 0 into x. Anything multiplied by 0 is 0, so I don't have to worry about the first term. I just have to worry about the second term. But then the same rule applies, -0, and then I only have to worry about the plus 10. And it is true. So this is true. Okay. Now, number 3, numbers between 2 and 5. I plug in 3. So I can do the same thing. This one might be harder, but it's okay. 3, so I write +3, and then I get a positive number minus a bigger, I do a positive number minus um, a bigger negative, and that's important. So I do +9 minus 21 plus 10, plus 9 minus 21 plus 10. And I don't even have to solve it to know that this will be a negative and this will be a negative. So you're basically multiplying, you're adding two negative numbers, which would make this a negative number, negative. And so 2 to 5 does not work. Finally, number five, 4, the fourth number that I plug in is 6. So I do 6, okay, 36 minus 42 plus 10. And I do another one, 36 minus 42 plus 10 is greater than 0. Let me see if that's true. So this would give me a positive number. So it's positive times positive plus another positive number. So this is greater than 0. And this is true. So it's true. Um, I can redraw the number line to make it cleaner, but honestly, both number lines mean the same, but I'm just gonna draw it with the lines now. -1 to 2, 5. So I have this. Oh, sorry. I take note that it's not an equals to, it's just a greater than sign. So I do this, and between -1 and 2, these are open circles. 1 and 2, lines like this. Okay, now this should be easy to convert into interval notation because it's just this. So this is the answer. And yeah, this is the final work of this one, and this is the final work of that one.